Hi, I'm Anna Skorobogatova. I'm a grad student at Princeton University under the supervision of Camilo Delelis. And in this talk, I'll discuss the interior regularity of area minimizing currents with high codimension. So, you have the plateau problem, you're given your boundary and you want to know what the behavior of area minimizing surfaces with this boundary is. And a nice framework in which to study this problem is in the setting of integral currents, because these are exactly a weak generalization of really nice, smooth oriented surfaces with multiplicities, and you have nice compactness properties there due to Federer and Fleming. But the problem now is that because we're in this weak setting, we allow for singularities. We allow for points locally around which the surface isn't really just one nice smooth guy with some multiplicity. And we want to understand what the size and the structure of this singular set is. And in codimension 1, the situation is much easier because in particular, you have this characterization of area minimizers where locally you can express them as a superposition of boundaries of sets of finite perimeter. And you don't have this in high codimension. And in high codimension, you have what are known as branch points or flat singular points, which are singularities where you blow up around this point, you get what's known as a tangent cone, and this tangent cone is really just a flat plane with some multiplicity. So you kind of lose sight of the singularity at these points, and this doesn't appear in the codimension 1 setting. It was the celebrated work of Almgren in the 60s, where he established a codimension 2 bound on this singular set for high codimension area minimizers. And yeah, the enemy is really these branch points, basically. And more recently, Camilo Delelis and Emanuele Spadaro simplified Almgren's proof and made the key aspects of it much more transparent. But it's still not known what the structure of the singular set is in high codimension, for example. So there's still kind of a lot more that's not known. So in this talk, I'll discuss the key aspects of Almgren's proof. I'll discuss my recent work on how to strengthen this dimension estimate to an M-2 upper Minkowski dimension bound. And I'll discuss how Almgren's frequency function plays a key role in understanding the behavior of the surface around these singularities. Yep.